So the NBA that came out this year is quite different to previous reports in that it's showcasing work that's been done over 5 realms: the marine, coastal, estuarine, riverine, and freshwater realms. So here's a brief snapshot of what the NBA detailed in terms of ecosystems and species on the threat status and protection status. So you can easily see here that the riverine and wetland systems are the most threatened ecosystems. But if you look at the protection level, it's the least protected. And therefore, species that occurs in our riverine and wetland systems are the least protected, yet the most threatened. So looking at IG Target 12 around assessing the status of our species, and in South Africa's species in particular, how do we now determine where our species are and what their threats are? By doing this, we collate historical information. So we digitize herbaria and museum specimens that provide the foundational information for species assessments and conservation work. We then run field atlasing projects and collect ongoing information from the field. And here I showcase 3 different monitoring programs, long-term. The SABAP is a bird atlasing project, which is now in its 2nd phase, run by the ADU at UCT. The CREW programs run by SANBI with support from Mapula Trust and the Botanical Society. And then EWT has their amphibian project. We are also quite opportunistic in looking at information that's coming out of our virtual museum and INAT. So all of this now citizen science products. Okay, so looking at virtual museums, looking at data that we pulled out of iNaturalist, just on the South African Red List project, you can see the amount of information we're getting for specific red listed animals and plants, and you can see quite a lot of endangered animals have already been uploaded onto INAT. And all of this information is now then red listed using the IUC and red list categories and criteria, and is posted on SANBI's portal. So these are the various taxonomic groups that are currently on the portal. And then for plants, we've got the red list of South African plant species. And the reason why this is separate from the animals is just because of the vast amount of data and species we've got for plants. But interestingly, on this website, you can clearly see that citizen science data has been used and has been acknowledged. So both with getting 2 additional populations for this critically endangered species occurring here in the Midlands, and then also getting threat information. So quite detailed information coming out of citizen scientists' data collection. Now moving on to the Cape. This map shows the areas of high concentration of threatened plant species within the biodiversity hotspot of the Cape Floristic region, and pay attention to the red blotches on this heat map. These are areas where the CREW citizen science groups work. So for obvious reasons, we work in areas of high concentration of threatened plant species, and they've been working in these areas since 2003. Currently, you can see the areas that are yet to be surveyed by our citizen scientists. So looking again, these are the areas and where the threatened species, so these are the highly threatened species, and this is the data that's yet to be captured. So quite astonishing to see just how much of data has been captured in around 15 years. So referring back to the IG Target 12 around status of species, this graph shows the national representation of our taxonomic groups. So the first indicator is the red list index, which means we take the list of species, and for plants we use a subset because we have so many plant species, and we look at trend analysis over a period of time. So for some of these taxonomic groups, you'd see that the trends are very short. So for example, the freshwater species, we have data for just from 2005 to now. So here there's a lot of gaps you can see looking at this trend analyses of what information we need for which taxonomic groups. So comparing that to the global targets, the bottom is the Red List Index global target for the amphibians, and you can see the South African target is way higher. So although amphibians are quite threatened, in South Africa, we are fortunate that it's actually less threatened than the global average. So amphibians are actually quite an important group for us to try to conserve. So looking at indicator 2 for the Aichi target on status of species, it's around the protection level. So we now know what species we have and what threatens them, but how well are we protecting them? And for this, we have 2 components. The first being how well represented are our species in our protected areas. And then the second is, importantly, what is the measure of management effectiveness within each of the protected areas when combined with protected area expansion priorities. And then also I'd like to detail what a protected species is. So a fully protected species is adequately represented with viable populations within the protected area and is effectively managed. And I'm detailing this, and I'll show you this in a moment. So looking at our species again, of the various taxonomic groups, these graphs shows the percentage of taxa that are protected versus, that's the whole lot of taxa, and these are the endemic taxa of those particular groups. So you can see clearly how well our species are protected, or least well, and bearing in mind how threatened these species are. So looking again at amphibians, there are species where entire ranges are in our protected areas, yet they are very poorly protected due to management not meeting ecological requirements. And these are just 3 examples from the frogs. We also have species that are listed as threatened, yet they are not protected. And these species are now a priority for protected areas expansion. So now looking at just the terrestrial realm, we know that it's globally recognized for high levels of endemism, yet because of the pressures, especially around human activities, 1/4 of South Africa's terrestrial ecosystem types are threatened. So looking at this again graphically, these are the terrestrial ecosystems, and you can see which are well protected, for example, our forests. Yet looking at the Indian Ocean coastal belt, it's the least protected. Grasslands are also not much protected, and you can see where the 50% markers and just how many of our terrestrial ecosystems are actually protected. So referring back again to the Aichi targets, looking at protected areas, so globally we need to protect at least 17%. The solid line is showing the protected areas of South Africa's terrestrial territory, and then the dotted line is the progress that we are making. So this is looking at protected areas and then also including the work of biodiversity stewardship work. So how can all of this taxa information now influence protected areas, and how do we expand our protected areas? So we've now created layers for each of the taxonomic groups, and pulled out all the records, the locality records for each of the threatened species, accurately geo-reference these records, and they're now available as layers for GIS. So I'm just showing 2 examples of the plants and the butterflies, and you can see just how many records we have. For plants, it's over 63,000. Butterflies, just under 16,000 records available. And we produced this map showing the categories of formally protected areas, sites that have species of conservation concern, and here I'm only talking about plants, which is not prioritized, and then sites where there are threatened species that are not protected elsewhere. So if you look at the priority sites, the darker the blotch, the more the number of plant species of conservation concern. So we have to be clearly quite openly, we can see that the Richtersveld has to be much more protected than it currently is. This information is also filtered down to the provinces, whereby we share the data annually with the conservation planners across our 9 provinces. And they then use them to make their provincial conservation maps. We further dumbed down this data for EIA practitioners. And this is just showing the data set of what we provide for EIA practitioners. And then we've dumbed down the science into levels of sensitivity. So an EIA practitioner can then slot in his locality, and he or she can easily see the area sensitivity. So if it's very high sensitivity, that site cannot be offsetted. It's completely irreplaceable, which then means that it has critical habitat for highly range-restricted species. So species that occurs only in an area of less than 10 kilometers squared. And then the different categories, obviously, that would have offsets. So this map now shows where the critical habitat sites are for plant species as compared to where the protected areas are. And you can see we've done this throughout the country, but most of the critical habitat sites are along the west of the country. Alarmingly, 56% of our sites are outside of protected areas for plant species. So the Crew Citizen Science Program has then taken on the critical habitat work, and these are the number of species per Crew node. So it's the Cape Floristic region, the Eastern Cape, KZN, and then we've combined Limpopo and Mpumalanga. And just over 2 years, our citizen scientists have managed to find a remarkable number of species. Bear in mind that these range-restricted plant species are quite cryptic to look at, and mostly inaccessible or high-altitude areas, and just showcasing a few of the species. We also then survey threatened species over a long period of time, and this is the 4K Crew group working in Cape St. Francis in the Eastern Cape, and they've been monitoring Brunsvigia, an endangered species. The first map you can see is where the species occurs, and then we managed to then map out suitable habitat models for this particular species. We've also got a site on the Cape Peninsula that has one critical habitat species, and then is suitable for various other species. So in terms of then offsetting habitats, we can now find more and more of these sites and start doing restoration work in them. So then, looking back at the work that's been done in KZN by Crew Citizen Scientists, you can see a vast number of the records and data collected for threatened plants has happened outside the protected area, and that's for various reasons of why we haven't gotten to the protected areas. But clearly it shows how much of records has been collected over the past 10 years, purely by citizen scientists, and how much of information can be gathered just by free labor. So in conclusion, I'd like to thank all our citizen scientists for almost 93 workman years of dedicated work within the plant conservation sector, and then obviously our funders for making all of this work happen. Thank you.